Upper air data from radiosonde and tracked balloons are an essential part of the global observing system. The earliest records date back to 1905, but the radiosonde network became established in the 1940s, reaching its full extent in the late 1950s. The service team for the in-situ comprehensive upper air network collects all available radiosonde station data for the CDS. In addition to providing access to the data via the data store, we calculate homogeneity adjustments and observation uncertainty estimates. This slide shows the distribution of stations delivering upper air temperature data. About 700 stations have long-term records, shown in yellow in the figure. But the dataset contains also data from more than 5,000 unique identifiers, which may have only very short records. This sketch shows the data flow and processing steps of our service. Data come from public archives, Met services, and the radiosonde intercomparison campaigns. They are then merged to remove duplicates and to concatenate pieces of longer station records. The merged data are then compared with modern reanalysis data such as ERA 5. The time series of differences between observation and reanalysis, which are part of the so-called analysis feedback, provide valuable information about spurious shifts in the observation records, which need to be removed. The difference time series also allow the estimation of random observation errors. The observations, together with homogeneity adjustments and error estimates, are put on a virtual machine at Compernicus premises. The observations and the metadata are structured following the so-called common data model for observations. This structure, used by several services providing observations, allow to build unified software for accessing and displaying observation data. Also, the provided file formats, namely netcdf4 and CSV, adhere to widespread standards.
Here you can see an example of such a combined record for relative humidity. The upper plot shows relative humidity at station Payerne in Switzerland. Over time, the radiosonde type and instruments change, yielding shifts in the time series. These breakpoints can be detected and a bias estimate can be calculated. The lower plot shows you the bias estimates calculated based on ERA 5 departures, indicating a major shift of instrument sensitivity around 1990. Removing such biases helps reanalysis efforts to become more reliable and make full use of past observations.
If such adjustments are applied to the whole station network, some discrepancies between neighboring stations, but also pervasive biases can be removed. This figure highlights the effect of relative humidity adjustments at 300 hectopascal. The spurious drying trends caused by changes of humidity sensors, as they can be seen over the United States and China, are much reduced due to the adjustments.
Thanks to the use of reanalysis information, so the background and reanalysis departures, it is possible to estimate the observation uncertainty using the statistical method developed by Desrosiers. Under the assumption that the background and observation errors are uncorrelated and the observation values are unbiased, it is possible to calculate an observation error that is independent on the metadata, but use only the reanalysis information. In the current version, we use the ERA 5 reanalysis, but this can be easily extended to other reanalysis in the future extension of the database. This means that we can calculate errors back in time, starting from the 1950s, when ERA 5 data becomes available. It is also interesting to compare these uncertainty estimates to the observation errors resulting from intercomparison campaigns, which is another key feature of our service.
The database, consisting of about 5,000 station files, resides on a virtual machine at Compernicus premises. It accepts requests encoded in JSON, which are translated to database retrievals using the H5Py Python package. The backend retrieves zipped netcdf or CSV files, which can be interpreted by the CDS toolbox or can of course be downloaded via the CDS API. The backend is efficient for extracting time series from single stations, but also for calculating a monthly mean for all stations. It is memory efficient and scalable, since retrievals of many stations or variables can be done in parallel. The service is not yet operational. Please look for insitu Comprehensive Upper Air Observations Network in the Climate Data Store. The service should go public in June. Meanwhile, on the next slide, have a first glimpse at our Toolbox Viewer app.
The Station Viewer Toolbox application offers access to each available radiosonde sent from 1905 to 2020 and will be updated continuously. Via a simple interface, the user can select temperature, humidity or wind data for each station worldwide. The resulting plot shows the profile of either day or night time. Additional and optional variables allow a closer look at the ascent. A variety of bias estimates provides adjustments for the original data. The dissocier uncertainty, calculated with different time windows, outlines the accuracy of the measured data. The Time Series Viewer Toolbox application is built for a glance at long-term radiosonde data and the change over the years. It offers the same options as the Station Viewer, but one can select any 2 points within the available date range and get the matching time series. Each standard pressure level can be chosen in the drop-down menu. This feature is especially useful for the detection of significant breaks in the data. This plot shows the temperature bias estimate from Vienna on 100 hectopascal. As you can see, there is almost no bias since 1996. The features of the toolbox are still limited, but could be upgraded in the future. More and new functions will improve the user experience.